So we are going to start our report for the physics practicals, and we are going to start with M1. Now, the physics practicals, they are very easy. If you have an understanding of the equation of a straight line and some other fundamental equations of mathematics, then this physics practical wouldn't really be a problem to you. Okay, so let's begin the class by starting with M1, as I've earlier said. So the first thing we do is to fill in our table and then complete the other parts. Now, when you do your practical, surely you are going to have these values, right? 44.60 and 44.61. Now, some of you did for 10 oscillations, while some did for 20 oscillation. Now, for this particular one, they did for 20 oscillation. So we are going to use that and solve. Now, most of you got your T1 and your T2 values before now. So don't bother copying from here. Some of you, if you don't have the correct values, then these values may just tends to guide you on which values is correct and which is not correct, and it will point you in the right direction. But don't copy the exact values that are here. You use your values in your manual to solve. Okay, so the first one, we have T1, T2, and then we have the mean. Now, what is mean? For instance, if you have two numbers, let's say A and B, and they say what is the mean of A and B, what do? You say the mean of A and B is equal to A plus B divided by 2. Okay, so what we are going to do basically here is to add T1 plus T2 and then divide it by 2. Okay, so let's do that for each of them and then see what it's going to give to us. So we have the first one, 44.60 plus 44.61. So we have 44.60 plus 44.61, and that is giving us 86.21 divided by 2. That will give us 43.1. So our mean here is 43.1. Now we are going to do the same thing for everything here. We have 40.60 plus 40.62 divided by 2. I think this will give us 40.61. So here is 40.61. Here is 36.53 plus 36.53 divided by 2 will still give us 36.53. Then 32.45 and 32.46. 32.45 plus 32.46 divided by 2 will give us 32.45 as the mean value, right? 45 something, but let's take 32.45, right? Then 26.25 and 26.24. Let's take here 26.25 as our main value. You add it. When you add it, the approximate value will also give us 26.25. Okay, then we have 22.20 and 22.24 divided by 2. This will give us 22.22. Okay, take note of that. So 20.20 plus 20.24 divided by 2 give us 20.22. Now, the next step we are going to take in this direction is to find the period. Now, the period, take it. Formula for period is equal to the mean of the time divided by the total number of oscillation. Okay, total number of oscillation or total number of revolutions. Now, in this case, we have 20 oscillations. Okay, so our period rather will be the mean all over the total number of oscillation. Is that not so? So what is that going to give to us? If we walk through that for each of them, you are going to have 43.10. Take note, you must make them to four significant figures. So we should change this to 10. Okay, 43.10 divided by, now the number of oscillation for this is 20 oscillation. So we are going to divide each of them by 20. And when you do that, this is going to give us 2.155. Okay, the next one is 40.61 divided by 20. This will give us 2.030. or 2.031 rather, right? And then the next one is 36.53 divided by 20, which will give us 1.827. And then we'll have 34.45 divided by 20, and then you have 1.722, right? 1.722. And then the next one is 26.25 divided by 20. This will give us 1.312. Let's take it like that. Then we'll have 22.22 divided by 20. This will give us 1.111. Now, have we gotten this? The next thing you do is to square each of the period, because what you have here is period is t, capital letter T, and then you have t square. What t square is telling you is that you should square the period. Okay, so if you square this period, what is it going to give to us? It's going to give us 2.155 square will give us 4.644. Are you getting it? Then the next one is 2.031 square will give us 4.12. 4.124, right? 4.125. 1.827 square will give us 3.338, right? 3.338, all to first significant figure. 1.722 square give us 2.965. So this one give us 2.965. And then you continue the processes for the rest of them, and you're going to get the following. So you continue the processes and you got this for the rest of them. Now at this point in time, what you need to do now is to plot your graph. Are you getting it? Now you go to your graph now and then you plot. Now the questions, there are questions here that we are giving. The question says, from the table, plot a graph of L against t square. So we are plotting a graph of L against t square. Which of them is L? This value here. Are you getting it? And which of them is t square? Is this value here. Are you getting it now? So we are going to take this table now to our graph sheet and then plot. Now you don't need to copy the table in your graph sheets. It's because where the graph is and where the table is are far. That is the reason why I want to take it to the graph sheets to plot. Okay, so let's do that. Now we have our graph table here like this. How do we plot this graph? Now the first thing we do is to rule two lines indicating the x and y axis. So I'm going to look for the lines to rule. So these are my lines and I'm going to rule them. Let's say you have the line like this. Now this line, we are going to name it the x, the y axis, and then we are going to rule another line. Let me take it a little bit up here, right? Let's end it here, and we are going to name this the x axis. Are we getting it now? So come up here and then name our lines. So here we say this is what? Y axis, and then here is what? X axis. Are you getting it? Now the graph says plot a graph of y axis, which is plot a graph of L on the y axis and then t square on the s axis. We may decide to say this should be x axis, right? You can make it x axis, write x axis here, and then bracket L. The unit is what? Centimeter. Or okay, this is the x axis is t square, so you can say t square. Let me rewrite this. You have t square, the unit is in second square, and then you come here y axis bracket, then L, the unit is centimeter. The next thing is your scale. So in the scale, you look at the values you have. What do you have? You have 20, 40, 60, 80, 100, 120. Now I don't know how small this will be for you in your phone to see. because I'm using a bigger screen here. I can actually see what is here. But this one, you don't really need this one to be in your graph. I'm just trying to, so that I will not start going back and forth. That's the reason why I have to put this here. Now you have 20, 40, 60, 80, 100, 120. Count everything you have here. This is 1, 2, 3, 4, 5, 6. Count everything you have here. It's 1, 2, 3, 4, 5, 6. Are you getting it? Then we have 6. I think so. We cannot use 2 centimeters. So let's say this from here to here is 1 cm. Now in your graph, remember that this one is oriented halfway. Are you getting it? It's oriented. Like, what I mean oriented, like I'm using portrait mode, while your own graph is straightforward. Like if you have a line, something like this is portrait. Then when the longer line is like this, then you get what I'm trying to illustrate here. So same thing is applicable here. My graph is in the portrait mode. Are you getting it? While yours is in the straightforward mode. So you can actually use 2 centimeters. Like what I mean is in your graph, you can use let 2 cm. That's what you should use in your graph. Are you getting it? Represent 20 units, okay, on y axis. This is your scale. Let 2 cm represent 20 units on your y-axis. Now, you are now going to come to your graph. Your own, no, I'm not talking about my own because I'm going to use 1 cm because of the shortness of this. So here becomes 10. Here becomes 20. In your own graph, after counting 2 lines, you have 20, right? Then here, what are you going to have? 40. Because I said 2 cm represent 20 units. So after 20, 40, then what? 60, then 80. Then 100. You see that my own will not be enough, but yours can be enough. So for my own, I'm going to use 1 centimeter. This is 1 centimeter here, but for yours, use 2 centimeters. So I'm going to change this to let 1 centimeter represent 20 units on the y-axis. So here becomes 20. Here will be what? 40. Here will be what? 60. Here will be what? 80. Here will be 100. Here will be 120. Here will be what? 140. Are you getting it? And here will be 160, and it continues like that. Is that understood? Now on the x-axis, what will be your unit? Now on the x-axis, look at what you have on the x-axis. You have 4, 4, 3, 2, 1, 1. Now I can decide to say let 2 centimeters represent 1 unit. So I can say on the y-axis, on the x-axis, let 2 centimeters. For my own case, you can also use that from your own case also. Let 2 centimeters represent 1 unit on x-axis. Now, this whole thing we are writing here is what is called the scale. So you may decide to put scale. Let this represent this. And another thing again that we forgot to do is the title of the graph. You must put in the title of the graph. For instance, this graph, I can title it. Now, all these ones, there's a space on top of your manual. Before the main graph starts, there's a space on top, right? And a plain space. That's where you should be writing all this. So in that space, I can write a graph of, this is a title and is a must. A graph of L against T square. Are you getting it? This is your title. This is a title of the practical. If you don't put your title, you are doomed. You must put your title. A graph of L against T square. Okay? Now, have we done this? We said let 2 centimeters represent 1 unit on the x-axis. So here will be 1, because this is from here to here is 2 centimeters. Everywhere in your graph from here to here is 2 centimeters. Are you getting it? Here will be 1. Here will be what? 2. Here will be 3. Here will be 4. Here will be 5. Here will be 6, 7, and it goes on and on like that. I even have space in my graph here, so I could have actually made it more realistic, right, by bringing it down. But let's work with this little space we have here. Okay, let's see how far we can go. Now, have we done this? The next thing I'm going to do now is to start my plotting. This is the most important aspect I want you to pay attention to. Now, you plot L on the y-axis against what? T square on the s-axis. So you have 120 here. You look at 120. What is the corresponding value of t squared? Is 4.64. So I will look at 120 here. I'll trace it. Are you getting it? This is 120. Where is my 4? This is 4. Now, between 4 and this is 4.5. True or false? This is 4.5. Between 4 and 5 is 4.5. So 4.5, after 4.5, the next two values is 4.6. So I can decide to take this point as my 4.65. Okay? Now the next one is 100. The 100 is what? 100 is 4.12. So I pick 100. Now, of course, you know this is 4. 4.1 will be somewhere around there. So I tick here as 4.1. Are you getting it? Then we pick 80. 80 is 3.38. So we take 80 and then we take 3.38. This is 3.25. I mean 3.5. 3.38 should be somewhere around here, right? So we take here as 3.38, right? Now we have 60 here, and then we have 2.96. 2.96 is approximately 3, right? So we take 60 here, and then we take 3, right? And then the next one is 40, and then we have 1.7. So we take 40, and 1.7 is just somewhere very close to 1.5. I mean 1.2 is very close to 2. So let me take here as my 1.7, right? It mustn't be that, but I just took that point. Now we have 20, and 20 is 1.2. 1.2. This is 20, and then you have 1.2. 1.2 should be somewhere here, okay? So I take this point as my 1.2. Now at this point in time, what do? You now rule a straight line, a line that will pass through. Are you getting it? At least 3 of the points or 4 of the points. So ruling a straight line, what are we going to have? Let me take this as my this, and then try and rule through this. Let me try and rule through this point. How many points entered? Now remember that these values are, now this is how my graph looks like, right? Now these values are just premeditated values, so let me push one of these values in so that at least 3 will enter. Now I'm showing you tricks now. Where was that one? That was for 80. 80 is 3.38. Okay, so be somewhere around there, right? So I took here as my 3.38. Now at least 3 of my values entered, although this last one is struggling to enter, but if you look at it very well, you discover that it entered. Now while I'm ruling my line, I must make sure that I rule it to the ending. Are you hearing what I'm trying to do here? I rule it to the ending. So let me continue my ruling again. Okay, this is not supposed to be so. I'm not so. Let me see if I can go back. Okay. So I took it from this point, right? Let me try and rule it to the end, and then you saw how I ruled it. Are you getting it? This one may not really be, if you take a ruler and rule, this may not be a straight line like that, but at least yours should make sense. Okay. This thing is giving me tough time to rule. Or let me just start from here and start ruling. Then anyone that enter. Nah lie, no fit work like this. Let's take it. Well, everybody got the concepts. It's getting difficult because I'm using a system, right? So this is the points I'm picking, and then get out, and then I rule again from this point down to wherever. It mustn't be a straight line, but just know what I'm trying to do here. Okay, so all these points, they entered into the graph. Okay, this one, let's assume this one entered, is very close, right? But it's not, it didn't enter that much. So let's assume that this point entered. Okay, and then you see at least 3 points entered. At least 3 point entered. Now, having done this, the next thing we are going to do now is to take our slope. Now, what I usually do for slope is I just take 2 points in the graph and then take them as my slope. So if I decide to take here as my slope, get out. No. But that's not where I want now. Anyhow, but you know what I'm trying to do here. You take here and then you rule it to this side. I don't know why this is don't want to follow this line. It's giving me its own options. Okay, let me use a normal line to rule. So if I have my ruler, what I'm going to do now is I'll trace it down. Everyone knows what that value is. Now you use solid lines to get your slope. Are you getting it? You don't just rule any kind of line. You use solid line to get your slope. So this, no. That was better. It was better. So I come here. Let me say this is the point. It's an assumption, right? I roll it down. And then this one was around 82. I don't know why this thing is trying to give me headache, but God is going to punish it. So I roll it down too like this. I'm not supposed to use arrows, but we have to break some protocols here. Anyways, but it's coming to what? 120. Are you getting it now? And then I took that point. Now, I'm not supposed to roll this down. I will roll it to the point at which we take our second point. Where's the second point here? Second point is here. So let's take this one as our second point, right? And then you now bring this one down like this. Okay, so this is now our slope of this graph. Now, the slope, I took 120 and 20. So I come back to my table now. I look at 120 and 20 and then look at the two values there. So we have 120. You are not to calculate your slope here, but I'm just trying to do it here so that at least we'll not be going back to this thing again. So the slope will be 120. Slope is usually the formula for slope. Don't write it inside your this, there's a space you write it. Are you getting it? Your worksheet. So your slope is change in y-axis all over change in s, which is equals to change in L all over change in T square, which is equals to change in L. What do you have here? We choose 120. So this gives us 120 minus the other value we choose here is what? 20. Are you getting it? Divided by T square. What value corresponds to 120? 120 is 4.6. So let's take 4.60 minus what value corresponds to 20? 1.2. So we took 1.2 here. Now when you punch this your calculator, 120 minus 20 will give us 100. Then 4.6 minus 1.2, I think this one will give us 3.4. Let me confirm. 3.4, right? 4.6 minus 1.2, 3.4. So 100 divided by 3.4 will give us 29. 29.4. Are you getting it? So that's our value for the slope. Now listen, the value for your slope is supposed to be within 25 to 29. Are you getting it? This value is on the very high side anyway, but it's supposed to be within the value of 29 to what? 25. This one is a very high one. That is to tell you that there's errors in this experiment. So the next thing that I want us to take note of in this graph before we go forward is the vertical scatter. Like I said, I'm just using this to do an illustration for you. Now the vertical scatter, how can we get the vertical scatter? Now the vertical scatter can be gotten by doing this. The vertical scatter, you can get it by doing this. Where is that monkey? Okay, you can get the vertical scatter. Now you look at this graph, the values that you have that are not on the line, the one that is farther away from either side, and then rule that part. For instance, this one now is very far away. Are you getting it? This one is the one that is farther away from the top. What I mean is, this is the line of best fit, this middle line here. Any value that does not fall into the line, that is farther away from the line, take that value and rule it. So in this case, you have the vertical scatter, I think starting from here, and then you are going to rule it this way. Okay, so that is for that. Now the second one is this value here, right? This value here is our vertical scatter. So I'm going to rule from here also to that value, and then rule it on a straight line. Now this line is not that straight because I'm using this. Now what you are now going to do is take a ruler. Let me show you what to do. Take a ruler and then place the ruler here like this, straight line like this. Or let me start the ruler from here, 0.0. Let's say this is the 0.0 of the ruler, and then place it in a straight line like this. Any value it gives to you from this line that is far away to this one that is far away from the under, that is your vertical scatter. Now let me assume the vertical scatter here is W is 0.5. These are assumptions. Are you getting? When you do your graph, you got the most correct value, so you know what to do, right? So this one here is 0.5. Let me assume that the vertical scatter W is 0.5 and our slope is 29.4. Okay, so everybody know how to get the vertical scatter. You have some points that did not fall into the line, right? Rule those points. Just one of them, the one that is far away from the central line, rule that one. You discover this one, you have this point, it does not fall into the line. Even this point does not fall into the line, but I decided to rule this one. Do you know why? Because this one is far away from the central line. You ruled only the one that is farther away from the central line. Okay, so this is our vertical scatter now, which is W is equal to 0.5, and our slope is 29.4. So we are done with this part. We take our slope 29.4 and then our vertical scatter 0.5. Slope is what? 29.4. Vertical scatter 0.5. Another thing that I forgot again is this point. You must put it as 0, 0. Take note of this. Okay, so that is that for this quest. So that calculation on slope that we did was supposed to be written here, right? So we can say our slope is change in y all over change in s, which is change in L all over change in t square, which we got as 120 minus 20 divided by 4.6 minus 1.2, and then the final answer was 29.4. So anything you are working on at all should be on your worksheet. 29.4. Now what is the unit? We have meter per second square. So the slope is meter per second square. Do you know why? Because t is what square, L is in meters. Okay, so we come back and then look at the next part. So we are done with this one. The next part says transform the equation t is equal to 2 pi root of L over g, so that L is the subject of the formula. So what we are going to do now is come here again. The equation says transform t is equal to what? 2 pi root of L over g, so that what? L becomes the subject of the formula. Is that not so? Now to make L subject of the formula, what do we do? First of all, we square both sides. So we come here and say square both sides. Now squaring both sides, what are we going to have? We have t square is equal to, if you square 2, it's going to give us 4. Then pi square, if you square pi, it's going to give us 4 pi square. Now if you square this, the square, we cancel the square root from here, so the square root will no longer be there. Okay, right? So here becomes times L all over g. Now this also is the same thing as t square is equals to 4 pi square L over g. This over 1, cross multiply this times this to give us, let me do that here because we still have much to do. Your book will be enough for you to write all this. Now t squared times g will give us what? t square g is equals to 4 pi square L. Now, to make L subject to the formula, divide both sides by what? 4 pi square. So 4 pi square divide by 4 pi square. This cancels this. L is t square g all over 4 pi square. Now, this is your L. So our L is, let's say, g all over 4 pi square times what? Times t square. Are you getting it? Now, recall L is equals to g times t square all over 4, okay, g all over 4 pi square times t square. Now recall the equation of a straight line. We've done that transformation now, right? So that is what is expected here. So you can decide to write it that L is equals to that value. Saying hence the slope of the graph L versus t square is. Now that slope is not trying to tell you that you should write that 29.4 there. What that slope is telling you is this. Now, equation of a straight line in your secondary school, you were taught that y is equals to ms plus c. Where in this case, if I want to write it, I can say y is equals to what? mx plus c. Now, why did I write it like this? Do you know that we plotted a graph of L on the y-axis, right? Look at this very well. We plotted a graph of L on the y-axis and then what? T square on the what? X-axis. Now, if you compare both sides, it means that if L is equal to y, which is of course what we did, and then x is equals to t square, of course that's what we did, automatically m becomes whatever that is close to t square. True or false? So m will be equals to what? Automatically, if you compare, here becomes g all over 4 pi square. So our m is equals to g all over 4 pi square. And in the equation of the straight line, which says that m is equals to, y is equals to ms plus c, our m is always the slope of that equation. So our m is equals to slope. So when they say what is the slope of the graph, what they are asking you for is m, and that is what? G all over 4 pi square. So you can now write, hence the slope of the graph is g is all over 4 pi square. We'll come back to this place now. So in place of this L versus t, what we are going to put here is g all over 4 pi square. You get the point now, right? Now, we'll now come back. The next question says, the measured value of the slope of the graph is. Now, what was the measured value? What was that value that we measured for the slope of the graph? We said it's 29.4. But the correct value is around 25, 26, and even 24 point something. But this one got 29.4, which is also within range because there are errors for every practical. Are you getting? So don't cancel your own if you got 20 something. But if you are getting 30 something, your oh no. Okay. Now, the next one say, hence the value of g is equals to. Now, how do you calculate the value of g? Listen, we say our m is what? G all over 4 pi square. Abi, let me come back to this. Wait, I think there's space here for me to solve this. Hence, the value of g is. Now, we said m is what? G all over 4 pi square. Now, all this should be in your worksheet too. Don't come and write it here. If there's space here, you can write it, but it should be on your worksheet. So, if m is equals to g all over 4 pi square, where's the value calculated for m? Value is what? 29.4, which is equals to g all over 4 times pi has value of 3.142 because pi is 22 over 7 from secondary school, b square. This is over 1. Cross multiply. When this multiply this, g will be 29.4 times, you use it to multiply 4 times 3.142 square. And then your g would be equal to. So you see that your value of g is dependent on the slope of the graph, which is 29.4 times 4 times 3.142 square. And this gives us 1060.966 centimeter per second square. Now, sorry, there's something that we did that the slope of the major slope of the graph is in centimeter per second square, not in meter, as I earlier said. So it's centimeter per what? Second square, because the table here, they say L is in centimeter, and we plotted the graph of L against T square, which is what? Centimeter per second square. Okay, so we come back here and then continue. So these are values for L. G gave us 11 point something. Now, what is the normal value for G? It's not 9.8 or 10.0. So if you got 11, it means there are some little error, because it's centimeter per meter. If I want to convert it to meter per second now, I will just bring this one backward 2 times 1, 2. This gives us 11.60 meter per second square. This is our value for G. But what are the standard values for G? Standard values for G are what? Are 9.8, right? And then we have 10.0. Are you getting it? These are the standard values for G. So if you are getting this, it means that your values are somehow more than the required. However, this is not a bad value, because you already have errors in the calculations. You are going to calculate the standard error. So our value for G is 1160.96. Then we write centimeter per second square. Then we have the standard error. That means those values that we are going to plus and minus. It should be plus and minus this value. Are you getting it now? So now, like I told you, what we determine the value of G is your slope. And I told you that the slope is around 25, 26, right? So if I change my slope now, for instance, let's say after you solved your own, you got 25. So this will be 25 times, so in place of this 29.4, what am I going to put? You just put your own value there. Okay, in place of the 29.4, you put your own value for slope here. So this gives us 25 times 4 times 3.142 square. What did it give to me? Exact value, which is what? 9.87 or 987.21 centimeter per second square. So you see, if you take this one 1, 2, it gives us 9.87 meter per second square, and these are the values for the slope. So when you are doing your own graph, now this is where I want you to actually pay attention to. When you are doing your own graph now, note that your slope should be within that value of 25, 24, 25, 26, and the rest. That's why I'm here to teach you. That's the reason why I want you to know what you are doing, not just plotting anyhow. Are you getting it? When you plot, you know that, okay, my value should be within this range. So that when you calculate, because what they will look at the end of the day is this value here. It is, let's say if you go get here, let's say 15, you are wrong. If you got here 10, is correct. 11 points is correct, because you are going to find the standard error. Now the next thing is the standard error. The standard error is equals to 4W all over N arrow. Now this should be your worksheet too. Now W is the vertical scatter, and I've shown you how to calculate the vertical scatter, right? If you don't remember, go back to that. Just reverse your video back to when I was plotting the graph. I showed you how to get the vertical scatter. Now I told you that the vertical scatter for this particular experiment, let it be 0.5. Of course, it's more than that. It's more than 0.5, but let's take it as 0.5. It should be around those 1 then, but let's assume it's 0.5. Then don't go and assume, measure your own and write it the way it is. Then our N is the number of values that you plotted, or number of points in your graph. Now the number of points can easily be calculated from here. 1, 2, 3, 4, 5, 6 points. So you come here and say your N is equals to 6. Then we have our range. Are you getting it? Now what is the range? Now the range is the lower value on the x-axis. The upper value on the x-axis minus the lower value. The value you plotted on the x-axis was 4.644 minus 1.234. 4.644 minus 1.234. So you come here and say 4.644 minus 1.234. Now this must be the values for the x-axis. Don't go and use your y-axis to calculate your range. It must be the x-axis. Okay, so when you punch this your calculator, what is this going to give to you? It's going to give you 4.644 minus 1.234, and this will give us 3.41. Okay, so put the standard error now, put this into the calculation. This gives us 4, standard error is 0.5. Then you have your n value is what? 6, right? Times 3.41, which is your range. Okay, and then at the end of the day, this times this, what is it going to give to us? It's going to give us 2.0 divided by 6 times 3.41. 6 times 3.41 going to give us 20.46, right? And then when you subtract 2 divided by 20.46, divide rather, it's going to give us approximately 0.1. So our standard error here is what? 0.1. This is the standard error. So it means that your value should be at least within the range, but 0.1 increase or 0.1 decrease. So you can put plus or minus 0.1. So this is how to get your vertical scatter. Now use your own values. Don't come and use my values. If you use my value, you are doomed. Are you getting it? Use your own word values and solve. So that is that. I've shown you how to get all the range, the vertical scatter, and the rest. I said the vertical scatter, you know how to get it. Go back to that video. The n is the number of points in the graph, and you can easily get it by counting this 1, 2, 3, 4, 5, 6. And then you come here, your arrow is the range. That means this first one minus the last one here, any value it gives to you is your arrow. So that is for the standard error. I think the next question here is explain why the graph fails to pass through the origin. Now, the reason why the graph fails to pass through the origin is because of what? Experimental errors. The graph refused to pass through the origin because of what? Experimental error. Do you know why? Because the graph is normally supposed to pass through the origin, but since it didn't pass, because of what? Experimental errors. Are you getting it now? Now, state two precaution, two sources of error and precaution you took to minimize it. Now, as a science student, when you see this question, the first error that comes to your mind that you don't even know how is the error due to what? Parallax. Then zero error of meter rule. Now, you use meter rule to measure most of these things, right? So the parallax error, how did you or you can talk about zero error first. Let me talk about zero error. Now, zero error of meter rule. It means that while taking your measurements, your meter rule should be placed at, or you're at zero error of meter rule, zero error. Then the steps you took to minimize them. Now, right, it was ensured, all right, I ensured that it was ensured that the meter rule was placed at the 0 point while making measurements. Is understood? So that is one. Then you can put random error. Now, under random error, you can put it was ensured that the place of the experiment was void of what am I going to use this? Was void of air. Are you getting it? And other random breeze. Now you know what I'm trying to talk about. You get it? So that is for the random error. Okay, that's for the random error. Another error again is systematic error. You use small angle, then under systematic error, don't write this random error, you can write systematic error. That is based on the practical that you did, based on the method. Are you getting it? Now, under systematic error, you can say it was ensured that the angle of oscillation was reduced. Are we getting it? To avoid conical oscillation. That is systematic error. That was how you avoided it. It's one of the questions here. Are you getting it? But that is for this. You use this to answer that question. Now, it is often recommended that the angle of swing of the pendulum be made small as possible. Why? Now, this is to avoid conical to avoid conical oscillation. That is the reason. Conical oscillation means instead of it to be going like here and there, it will now be rotating. You understand? That's what it means. So to avoid conical oscillation, the angle at which you actually did your pendulum should be made as small as possible. You know your pendulum is, let's say this is your stand, right? And then you have your thread, right? Now what we are trying to say is that the angle at which, when you, let's say you are the one here, when you want to make your practical, you should not draw this thing to somewhere like here. If you do this, the angle is very big, and when you do this, instead of the something to be going like this and coming back, are you getting it? What will be happening is that it will be undergoing conical oscillation, so the something will be turning around like that. That's why they say you should use small angle of oscillation somewhere like this, so that it can easily go to and fro. Okay, now the next question says, in your opinion, will the value of G be affected if the size of the bulb is varied? No, because the period, because G does not depend on the mass, does not depend on mass or size, does not depend on mass or size of the bulb, of the pendulum bulb. Okay, of the pendulum bulb. Now, conclusion. Now, what is the conclusion from this experiment? Conclusion is that the value of G was estimated by measuring the period of oscillation of a pendulum bulb at different lengths. Hence, T is equals to 2 pi root L all over G was verified. Are you getting it now? So this is how to go about this question. I think that is for everything about M1. Thank you very much for your time. Now, if you want to get quality content and you want to get more of the practical solutions, you should actually subscribe to our paid course on Telegram. By so doing, you get access to other videos and other practicals, including the chemistry and other part of the physics. Thank you very much for your time, and God bless. Bye.